In this bite-sized tutorial, I would like to explain what is R-square and how to compute R-square using Python. First, let us recap on the definition of variance. The formula of variance is given here. It's the sum of the square differences between each data point and the total mean divided by the number of data values. If we would like to explain the variance visually, we could plot out the data points. The red line represents the total mean. We could compute the square differences between each data point and the mean. Then we can compute the variance using the formula. Next, let's recap on the definition of mean square error of a regression line. The mean square error can be calculated by squaring the residual errors of each data point, summing the square errors, and divided by the number of data points as given by this formula. And the residual error is just the difference between the predicted data points and the real data points. If you would like to explain the mean square error visually, we could use back the same data points. The red dotted line now represents the regression line. We compute the square residual error for each data point. Then we compute the mean square error using the formula given here. Finally, we come to the definition of R square. R square is 1 minus the ratio of mean square error and the variance. If the mean square error is same as the variance, then R square is 0. If the mean square error is 0, then R square is 1. So R square is always lie between 0 and 1. Another way to look at R square is taking the ratio of the explained variance over the total variance. Explained variance is the difference of the variance and mean square error, and the total variance is the variance. If the variance can be explained by the regression line, then the R square is 1. On the other hand, if the regression line is not able to explain the variance of the data point, then R square is 0. Next, we will move to Jupyter Notebook to compute R square using Python. First, we will import the steps library from the SciPy package. Then we create some data sets for illustration purpose. We will use the linear regressions from the steps library to compute the slope, intercept, R square, and p-value of the regression line. We then define a simple regression function to return the predicted value. We plot the regression line and the data points as shown below. So the R square value of the regression line is given by 0.767. So we are now going to compute the R square value manually using the formula that we learned previously. First, we will need to compute the mean square error. We could get the mean square error from the scikit-learn package. Then we use the formula for R square to compute R square. We get exactly the same value, 0.767. So this concludes the bite-sized tutorial on R square. If you like this video, please comment, share, and subscribe to our channel. Thank you.